This video is on Unit 8 on Trigonometry, Chapter 16, the unit circle, Lesson number 1, Angles and Angle Measures. In your notes here for angles in standard form, the first bullet says that an angle on the coordinate plane is in standard form when the vertex is on the origin and one ray lies on the positive x-axis. So I'm going to highlight these parts. An angle that's in standard position, again, the vertex is at the origin. And then you have a side of the angle that's always going to be on that positive side of your x-axis. Now, the other side of the angle can be floating around anywhere in the coordinate plane. The ray that's on the x-axis is called the initial side. So that thing that I have highlighted yellow right now is the initial side. The other ray is called the terminal side. So the terminal side is the side of the angle that is going to be moving. Think of a spinner, like that you might see if you were playing Twister. So that spinner, that side that's moving around would be referred to as the terminal side. Counterclockwise rotations result in positive angle measures. So if this terminal side is going up, that results in a positive angle measure. If that terminal side is rotated down, it results in negative angle measures. And I'm gonna go into a little bit more there in just a second. One full rotation is 360 degrees. So let's look at the rotations and the degree measures. So the initial side starts at 0 degrees. If we go up, if the terminal side goes up, you can see here that right at the top of the y-axis, we've got 90 degrees. As we continue on around, we've got 180 degrees, which is on the other side of the x-axis. Continuing on around the coordinate plane, down here at the bottom of the y-axis would be 270 degrees. And as we continue all the way back around to the initial side, we end with 360 degrees. So one whole rotation is 360 degrees. Now, if the terminal side starts going in the downward position, that's going to indicate negative angle measures. So down here at the bottom of the y-axis, this would not be 270. It would be negative 90 degrees. And as I continue on around, on the other end of the x-axis would be negative 180 degrees. Continuing on around, this would be negative 270 degrees. And then all the way back around is going to be negative 360 degrees. So that's just kind of a brief explanation on the degree measures that you're going to find in the coordinate plane with these angles. Drawing angles. Let's talk about drawing angles. So the directions here say to sketch an angle with the given measure in standard position. So the first thing that we're going to start with is the vertex and the initial side of the angle. Now, when I think about a positive 75, I automatically put the terminal side going up. So we're going to be traveling up. And 75 degrees is close to 90. So I know this is 90 up here, right? So 75 is going to be just shy of that. I'm going to put that terminal side right there. And then I'm going to add an arc and an arrow. Now, what that arc and arrow are doing for you is they are indicating the direction in which that terminal side went. So again, it starts on the x-axis, the positive side of the x-axis, and it's going up. And there's your 75 degree angle. Versus number 2, where you've got a negative 160 degrees. So again, we're going to start with the vertex at the origin, and the initial side is on that positive side of your x-axis. The terminal side on this one has got to go down because it's a negative 160 degrees. So again, this is going to be negative 90. Well, 160 is going to be past that. All the way over to the other side is negative 180. So obviously, that terminal side is going to be somewhere in quadrant 3. And it's going to be closer to the negative 180 than it is the 90. So I'm going to put my terminal side about there. Again, I'm going to add an arc and an arrow to indicate the direction of that terminal side so that that's a good representation of a 160 degree angle in standard position. I do want to quickly talk about number 3. In number 3, you've got 430 degrees. Now, 430 is more than 360. And for me, I need to know how much more than 360. So if I take 430 minus 360, I get 70 degrees. So with this one, again, we're going to start with the origin. We're going to start with that initial side. It is positive, so my terminal side is going to go up and then around. There's your 360 degrees. And I need to add an additional 70 degrees to that to get a whole 430 degree rotation. So 70, we're going to say, is probably right about in there. And there is a representation of a 430 degree angle in standard position. All right, so now let's talk about radians versus degrees. Degree measure is a way to measure an angle. A radian is a unit of angle measure based on arc length. 1 radian is defined as the measure of the angle formed when the radius is equivalent to the length of the intercepted arc. So the radius, which would be the distance from the center to the circle, is equal in length to the intercepted arc. That's defined as 1 radian. It goes on to say here to recall that the circumference of a circle is 2 times r times pi. Therefore, 360 degrees is 2 pi radians, and 180 degrees is just 1 pi radians. Now, typically, when we are writing measures in radian measures, we don't write out the word radians. We just know that when an angle measure is given to us in terms of pi, that is assumed that that's a radian measure. There are 2 formulas here that you need to be familiar with: converting degrees to radians and also converting radians to degrees. So if you have radians, to get radians, you're going to take the degree measure and multiply that by pi radians over 180 degrees. And to get degrees, you're going to take your radians and multiply by 180 over pi. Now, full disclosure here, I do not have those formulas memorized. All I do when I'm converting from radians to degrees or degrees to radians is I pay attention to what needs to cancel and then just put the correct units so that they'll cancel. For example, we know that when converting between degrees to radians or radians to degrees, it involves a pi and it involves 180 degrees. So if I'm converting this 30 degrees to radians, I'm going to multiply by a fraction so that the degrees are going to cancel, which means the 180 degrees needs to go in the bottom and the pi is what's going to go in the top, because it all goes down to those things that need to cancel. And degrees, the units, need to go away there. And you end up with 30 pi over 180. And then, of course, we want to make sure we reduce that. So 30 pi over 180 is going to reduce to pi over 6. If you have 1/6 pi, it is the same thing. So pi over 6 or 1/6 pi is the same answer. The only difference between a positive and a negative, like on example number 6, is if you have a negative degree measure, your radians are also going to be negative. So if I start out with negative 220 degrees, I'm going to multiply again so that the degrees are going to cancel, which means the pi needs to go in the top. So I'm going to cancel the degrees, and I get negative 220 pi over 180, and then we're going to reduce that, and we get negative 11 pi over 9, or negative 11 ninths pi. Again, both of those are the same answer. So when we want to convert to radians, from radians to degrees, like in 7, 8, and 9, again, full disclosure, I do not memorize the formula. I'm going to multiply by a fraction, and I know that that pi needs to go away. So I'm going to put the pi in the bottom. I need it to be in degrees, so the 180 goes in the top. So then we'll get rid of those, the pi's, and then you're going to probably use your calculator here to multiply your 4/3 times 180. So 4/3 times 180 gives me 240 degrees. Okay? And again, if it's a negative radian measure, then you're going to have negative degree measures. So let's continue on. Coterminal angles. Angles in standard position with the same terminal side are coterminal angles. Give two coterminal angles for each given angle, one positive and one negative. So our answers here in 10 through 13 are one answer. You're supposed to be having two answers. One would be positive, one would be negative. Coterminal angles are difficult to describe in a video. I'm going to give it my best shot. So with coterminal angles, as a matter of fact, let me go back. I'm going to go back a page to try to explain coterminal a little bit better. I want you to go back to example number 1. So this terminal side, and I'm going to highlight this terminal side, gave us an angle measure, a representative of 75 degrees. What if, change my color, what if I went down? So I didn't move that terminal side, but I created a different angle with the same terminal side. And I would need to know, well, what is that measure? Well, that measure is whatever 360 degrees is minus the 75. Or I should say 75 minus 360, because it would be a negative angle measure. So 75 minus 360 would be negative 285. So that is a negative 285 degree angle. That's a coterminal. So 75 and negative 285 are what we would call coterminal angles because they have the same terminal side. The angle itself in a coordinate plane in standard position hasn't changed, hasn't moved, but you've got another angle measure. One other way to look at this is if instead of stopping, I just kept going all the way back around to that same terminal side. So to find that angle measure, it would be 75 plus 360. So if I take 75 plus 360, I'm going to get 435 degrees. So 75 degrees, negative 285 degrees, and 435 degrees all have the same terminal side, but we just added and subtracted 360 to get to another angle measure. And that, in a nutshell, is what's happening when we talk about coterminal sides and coterminal angles. Coterminal angles share the same terminal side. And to get to another angle, you're going to add or subtract 360 degrees. Or in example 12 and 13, it's going to be add or subtract 2 pi. So let's look at example number 10. I'm going to take 65 and I'm going to add 360. And that gives me 425. I'm going to take that same 65 degrees and I'm going to subtract 360 and get negative 295. So these two angle measures share the same terminal side with the 65-degree angle, and they are all coterminal. For example, number 12, I have 13 pi over 18. So we're going to take 13 pi over 18. We're going to add 2 pi, and we're going to also take that 13 pi over 18 and subtract 2 pi. So 13/18 plus 2. How about, I forgot the plus 2. So 49/18. And then 13/18 minus 2. And we get negative 23/18. I will say this, you may have to add or subtract multiple times in order to get one positive answer and one negative answer. If you look at number 11, if I take 540 degrees and I subtract the 360, 540 minus 360 is still a positive answer. It's positive 180. So I would actually have to take that 180 degrees and subtract another 360 in order to get another coterminal angle that's a negative answer. So the same thing might happen on number 13, possibly. Moving on. Reference angles are a very important part of the trig that we work on in here. So for an angle theta in standard form, the reference angle is the positive, very important word here, positive, acute is the other important word, angle formed by the terminal side and the x-axis. Sketch and find the reference angle for each angle. So the first thing that you want to do is sketch the angle. So for number 14, I'm going to sketch 225. So there's my vertex, there's my initial side. 225 is greater than 180, but less than 270. So this is going to be somewhere in quadrant 3. It's going to be, let's see. It's going to be more than 180, less than 270. How much more than 180? So if I take 225 minus 180, what do I get? 45? So I'm right in the middle of that. So there's your 225 degree angle. So here's how I'm going to try to explain a reference angle. You're going to put your pencil on the terminal side, and then you're going to go to the closest x-axis because it has to be an acute angle. So if I'm here, I'm going to go back to the x-axis there, and I need to know what that angle measure is. Well, we already found it. It's 45 degrees. So my reference angle here is 45 degrees. Again, the reference angle is formed by the terminal side and the x-axis, whichever axis is the closest. It could be the positive side or the negative side. So let's look at number 15. Negative 310 degrees. Here's my vertex, my initial side. Negative 310 is not quite 360. There's negative 270. I think I need about another 40 degrees. So not quite halfway, but right there. So there's negative 310. Again, your reference angle is formed by that terminal side and the x-axis that it's closest to. So this terminal side is closer to the right side of your x-axis. So there's your reference angle, and you've got to figure out what that angle measure is. So a lot of what we do in this particular lesson is just going to be some common sense. So the answer here is going to be positive. And if you subtract and you end up with a negative, just change it to a positive. I need to take that would actually end up being a whole rotation there, which I know is 360 degrees. So if I take 360 minus the 310, that leaves me 50 degrees. So my reference angle is 50 degrees. All right, so let's look at number 16 because this one's in radians. The first thing I would do if I were you is I would convert this to degrees. Since you're probably not very familiar with radian measure and where it all falls yet, I would go ahead and convert this. So the pi's are going to cancel, and then you're going to end up with 120 degrees. So we can easily find where 120 degrees is going to be. You've got your vertex, you've got your initial side. So the terminal side is going to be greater than 90, but less than 180. So it's going to be in quadrant 2. I'm going to say right about there. All right, so if that's the terminal side for my given 2 pi over 3, I'm going to uncover this pi. That's the terminal side for my 2 pi over 3. My reference angle is going to be created again by the terminal side and the x-axis. So this one's coming back to the left side of your x-axis. The key here, y'all, is the word acute. These reference angles are always acute angles, so less than 90 degrees. So you're always looking for the angle formed by the terminal side and the x-axis that makes that acute angle. Now, what is that angle? There's a couple of different ways we can find that answer. Earlier in this video, I mentioned that 180 degrees is the same thing as 1 pi. So if you were doing this in degree measures, you would take 180 and subtract the 120 degrees to figure out what that reference angle is. We can do the same thing and leave it in radians. I'm going to take that 2 pi over 3. I'm going to do this way on purpose, and I'm going to subtract the pi. So basically what I'm doing is I'm taking 2/3 minus 1. So look what happens. If I take 2/3 and I subtract 1, the calculator is going to tell me that's equal to negative 1/3, which is fine. My reference angle is 1/3 pi. All I did was I made positive. I need to know what that measure is. That measure is a positive measure, and it's measured in as 1/3 pi. Once you subtract, you get 1/3 pi. Now, what you could do, if radians are still very confusing, if I take 180 and I subtract the 120, we get 60 degrees, and then you would take that 60 degrees and convert it back to radians. So the last part of this lesson is on our trig functions. So let theta be an angle in standard form, and point P, which is ordered pair XY, be a point on the terminal side of theta. So in the picture on the left, you have your angle in standard position. You have point P over here on your terminal side. And the distance from P to the origin is going to be your radius. So the distance from P to the origin is your radius. And you can hopefully see that in the picture. So from P to the origin is going to be called the radius. And the distance, that radius, can be found by using a form of your Pythagorean theorem. Now, what's going to happen here is you're going to drop a perpendicular from that ordered pair down to your x-axis, and it creates a right triangle. So that's why this is referred to as your trig functions. So that vertical coming down to your x-axis creates a right triangle. The distance from the origin to that perpendicular is your x, because it's on the x-axis. The vertical is your y. And then, of course, that distance from the point to the origin is the r. So sine of theta is going to be opposite over hypotenuse, which is going to be y over r. So theta that we're referring to is this. And it's the same thing as the y over r. So opposite over hypotenuse. Cosine is going to be x over r. And tangent is opposite over adjacent, so y over x. In that triangle, in this triangle that's created, we're saying that the theta that we're looking at in the triangle is there. So that's where you get your opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. So your cosine of theta is just going to be the reciprocal of your sine. So r over y, r over x, and x over y. Now here's where this becomes important. As we're working question number 17, it says point P, which is at 5, -2, is a point on the terminal side of theta in standard form. Find the exact values of the trig functions of theta. So what we're going to do is we're going to plot 5, -2. So 5, -2, we're just going to say lives right about there. And we're going to draw a line from the origin to that point. And then we're going to draw a perpendicular from that point to the x-axis. So the distance here is my x. The vertical is my y. And then the distance from the origin to the point is your radius. So in this example, x is equal to 5. So x is equal to 5. Y is equal to -2. Actually, yes, y is equal to -2. And then we have got to find the radius. So to find the radius, we're going to plug that into our Pythagorean theorem. And your 5, this is a distance, this is a distance. So we're going to drop that negative to represent the distance. So 5 squared plus 2 squared is equal to r squared. So 25 plus 4 is equal to r squared. So 29. And then square root, and you get the radius is the square root of 29. And then using those formulas that I just gave you a second ago, these up here, we're going to fill in the rest. Now, you can memorize those, or you can go back to your basic trig functions. I know r is now 29. The sine is opposite over hypotenuse. So I end up with a -2 over the square root of 29. Now, when we are doing this part, you do have to follow the signs, that y is actually a -2, and we have to bring that into these trig functions, these ratios. So don't forget the negative there. As you're doing the Pythagorean theorem, it's not going to matter because you're squaring the negative. And then, of course, you're going to have to fix that fraction, multiply by the square root of 29 over the square root of 29, and you get -2 square root of 29 over 29. All right, let's do cosine. According to the formula up here, cosine is x, which is 5, divided by r, which is the square root of 29. Again, you can go back to your triangle that we looked at over here and follow your regular trig functions. Cosine is adjacent, which would be the 5, over the hypotenuse, which is the square root of 29. And then multiply by the square root of 29 over square root of 29, and you get 5 times the square root of 29 over 29. The tangent is y over x, and y is -2, and x is 5. So now to find those inverse functions, we just need to flip, and I'm going to go back to the originals, and I'm going to flip this, keeping the negative in the top, flip, and flip. So there are your notes for chapter 16, lesson number 1 on angles and angle measures.